So the last video was on 2.5, which is writing linear equations, but now I'm going to jump really far up, and it might seem weird why I'm doing that, but what I did on the last few videos was focusing on inequalities. We looked at linear, absolute value, nonlinear, and then we jumped into looking at a linear equation, graphing a linear equation, and writing a linear equation. What 5.5 is going to do is put these two ideas together. And the way it's connecting them is because we're going to graph linear inequalities now. And by graphing them, not the way we graphed them on a number line before, was like graphing a solution. Before, the linear inequalities where we looked at only contain one variable in them. Now we're going to have both x and y, just like how we've been graphing. And just like how we graph, we're going to need, so the section is inequalities and systems of inequalities in two variables. And the reason why is because we're going to have the two variables as x and y. And we're going to need this again, y equals mx plus b. We're going to have to remember how to graph using the slope-intercept form. And we also have to recall all the inequality symbols. Remember, we had this symbol. Don't forget, on this side, everything had to be smaller. On this side, it had to be bigger. For the next symbol, this had to be bigger. This side has to be smaller. For this symbol, this side has to be both smaller and equal to. For this one, it could be bigger or equal to. Similarly, with this symbol, this was either bigger or equal. This side was smaller or equal, meaning they were the exact same number on each side. So, for example, like 5 is less than or equal to 5. Even though their 5 is not greater than 5, it is equal to it though. So that is still technically a true statement. And that's what we want. We want our statement to be true. We don't want a false statement. So we're going to be putting these two ideas together. Is the way we graphed using sloped-intercept form and understanding these. I'm just going to jump right into an example, just so you can see how this is going to work. But just like the way we graphed using slope-intercept form, we have to isolate our y. Oh, and that brings up another important thing, that remember when now we're going to be trying to isolate y, but since we're dealing with an inequality, we have to be careful when we isolate it. Remember, an inequality is very similar to an equation when we're solving them, but the main difference was that when you either multiply or divide by a negative with inequalities, sorry, I have to sound it out. Inequalities, you change the inequality. So remember, whenever you're multiplying or dividing by a negative, you have to switch the inequality. So that was another big important one. So these three things are what we need to be able to solve these problems. So let's just start with an example. And maybe you remember these. These type of examples involved like graphing shaded regions. So for example, we're going to be just graphing essentially. That's what this section is about. And we're going to graph. Let's look at our first example. It's going to be 3x minus 2y is less than 6. So again, it looks exactly like the linear equation, just instead of not having equal to, it has the less than symbol. So let's graph it, not using a table, because even though the table is one of the best ways that you'll ever know how to graph anything, because it's going to help you graph quadratics, it's going to help us graph square roots, logarithms, exponentials. But for now, we're going to just graph using slope-intercept form because it makes this problem more efficient. But I want to isolate my y first. So to do that, I'm going to subtract 3x to both sides. This is going to cancel on the left-hand side, and I'm going to have negative 2y less than, and I'm going to write it again, x first, and then the y-intercept after. So 3x plus 6. Again, it's not the y-intercept until the y is isolated, so sorry if I made that confusion. But now I have to divide, and here's the key thing. I'm going to use the same color. I'm going to divide by negative 2. Remember, I'm going to divide that 2, just like in the equations, I have to do it to the entire left-hand side and right-hand side. But the reason why I used this color was to match this rule here, because we are dividing by a negative. So that means we're going to have to switch this inequality. So this simplifies. Don't mix up, like this is cancel. 3x minus 3x is 0. But negative 2 divided by negative 2 is just 1. It has that positive 1 here in front. But then, so don't, I know I'm slashing it, but I hope you're distinguishing the difference between cancellation and simplification. So here, this is now going to switch to this symbol. And again, that means this side is going to be the bigger side. This side is going to be the smaller side. That's going to become really important when we graph it. But here, I have to, remember, break it apart so I can distinguish the difference between where my slope and my y-intercept is. So I'm going to, when I break this negative 2 with this negative 3, that's just going to become positive 3x over 2. Whereas when I break it up with this, I know 6 divided by 2 gives me 3. But this positive and that negative is going to be negative 3. Hopefully I didn't lose people in that. All I did is break it apart. Negative 3x over negative 2, which will simplify to 3x over 2. And then 6 over negative 2. And 6 divided by negative 2 will give you negative 3. Hopefully I didn't lose anybody. So up to here, again, I combined the idea of linear equations and inequalities right now. Now I'm going to add this idea that we learned about inequalities, which there was a quiz on this, and this is the answer to that quiz that I did about a video or two ago. So now we just have to graph this. But we're going to graph it using slope-intercept form. Remember, the way we did that, we needed to identify what the slope was. So the slope here, again, it's not just the coefficient of x. Don't forget that there's this 2 down here. That's part of your slope. And we have to be able to identify our y-intercept. And our y-intercept, remember, our y-intercept is not just the number. It's 0, negative 3. It's a point. Now, I can graph. Hopefully there's a big enough graph here that you'll be able to see. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hopefully you can see my tally marks without me having to label them. So here, I'm going to mark this point. So remember, the way we always start at the origin, but since our x is 0, I'm not going to move left or right at all. I'm actually going to go down 3. So 1, 2, 3. And this is where my point is. I'm going to shade that in. And that's where my point is. That's where my y-intercept is. Remember, y-intercepts are points that are on the y-axis. But remember, this slope was rise over run. And the rise here is 3. It's positive, so I'm going to go up 1, 2, 3. And then run over 2 to the right because it's positive, so I'm going to go 2 to the right. And then I'm going to have a new point right here. And that is enough for me to make a line. Remember, 2 points is enough to make a line. So all I have next to me are these wheat crackers from Sprouts that I'm going to use to make a line. So I'm going to make my line here. But I actually did this wrong. And the reason why it's wrong is because now we have to start introducing the idea of this inequality. There is no equal to part in this. So this is technically supposed to be these broken lines. Hopefully you'll be able to see them. So there has to be, it has to be a dotted line. It can't be a solid line because it's not equal to. So that's really important. Hopefully I'm not losing anybody there when I did that. Shouldn't have done a solid line. I'll do another example that has a dotted line as well. So hopefully I don't lose anybody. So here, now this side is the bigger side. This side is the smaller side. So I'm going to reference the y-intercept. And that's the reason why we use the slope-intercept, or what I like to use the slope-intercept for. Because since I have a y-intercept, and I have to think about where are the y values bigger. So remember, because the y has to be bigger. So I want to know where my y values are bigger. Are they bigger down? So on this side of the line or above the line? So remember, greater is always, when we're looking at a number line, the bigger numbers are on the right, the smaller numbers on the left. But now that we're dealing with the y-axis, the bigger numbers are always above and the smaller numbers are always below. Since y has to be bigger, then this is going to be your solution. Right here. Maybe this brings up some memories, but that's the way you would graph this particular linear inequality. So again, you want to write it in slope-intercept form. But you want to be careful when you're isolating your y if you ever divide or multiply by a negative. And then graph it using your slope-intercept form by identifying your slope and your y-intercept. But before you actually start graphing your line, now's the time to look at the inequality again. If it doesn't have an equal to, then it has to be a dotted line. If it has an equal to, you're going to have to make a solid line. And then once you're done with just the line, now you have to find the shaded region. So the shaded region, you have to go back to the inequality and see, look at your y. If y is bigger, then that's going to be above. And then literally the values that are above this y-intercept. So it's going to be on this side. And where if y was the smaller one, it'd have to be the values that are smaller, which would have been this area here on this side. So most people, when they teach this, they always ask you to use points to plug into this inequality to verify if the inequality is still true. But using this idea here voids that. There's no need, because as long as you know y is bigger, that is going to be your answer. But for the sake of checking, so you can see that this is true, I'm going to choose a point that I can definitely tell is on this side of my shaded region. And that point I'm going to use as the origin, just because that is a nice number to use. And don't forget, the origin is 0, 0. So I'm going to plug it into, it's always good to plug it back into your original one, so just to make sure you didn't make any mistakes along the way. So the original one, it was 3